Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, I'm going to discuss one important thing that is called as LPC1768 microcontroller and its architectural overview. Basically, this microcontroller is a 32-bit microcontroller, and today we'll understand its internal architecture of LPC1768, and in the later upcoming videos we will understand how to do the programming for this LPC1768 microcontroller. So without further delay, let us start today's video. Before starting video, so if you have not subscribed my channel, please subscribe my channel and motivate us to create videos like this and also gain the knowledge on embedded system. So without further delay, let us start today's video, LPC1768 and its architectural overview. So guys, already I have posted many videos on microprocessor and microcontrollers. Please go through that to understand what is a microcontroller and microprocessor. So I'll put my links in the description as well. So before going to LPC1768 microcontroller, so this document, currently what you're seeing, the document, no, this is called as LPC1768 user manual. This is LPC1768 user manual. If you want to find it, you can just type it LPC1768 user manual in the Google. It is around 800 pages approximately. It is, you can see here, 840 pages it is. So in this document, they have explained almost all peripherals which are available in the microcontroller. You can see here, they have explained in the form of chapters. Chapter number 1, chapter number 2. Chapter number 1 is introduction in information, chapter 2 memory map, and goes on like that. So totally in this document, so 35 there are total 35 chapters are available in this document, and it's very important to know the user manual if you want to understand any microcontroller. If you want to understand its internal architecture and its programming hardware, everything will be explained in this type of document. So for this microcontroller, what you can do is just you can search in the Google LPC1768 user manual. So if you search it, you will get a document, and the same document currently what you're seeing on the screen. Now let us go to the content here, that is simplified block diagram of LPC1768 microcontroller. I have already told in the introduction part, the LPC1768 microcontroller is basically a 32-bit microcontroller. This is one important thing you should know. This is a 32-bit microcontroller, and inside this very important thing, the core processor which is running inside is the ARM Cortex M3. ARM Cortex M3 is a very advanced processor. It's advanced processor. Currently, the most of the industries are using ARM Cortex M3. And in this microcontroller, we have used, in the sense, the silicon manufacturers, they have used ARM Cortex M3 processor inside this LPC1768 microcontroller. So the core thing is LPC for this LPC1768 is processor. And before that, I just forgotten to tell you, this LPC1768 microcontroller is manufactured from NXP semiconductors. This LPC1768 microcontroller is designed and developed by NXP semiconductors, and it's previously it was also known as Philips. Okay, so this is the one additional information you should know. Okay, now coming back to the topic here, the ARM Cortex M3, the core processor which is running inside the microcontroller is called ARM Cortex M3, and then this processor is connected to the multi-layer AHB matrix. So this currently what you're seeing now. So this is the AHB matrix, and it is nothing but it is a connecting terminal. This AHB matrix is nothing but connecting terminal where you can connect the different peripherals to the core processor. Okay, just you try to understand that much. So this controller is having not only this microcontroller, if you go to any ARM based microcontrollers, definitely there will be AHB matrix, and this AHB matrix is acting as a terminal, port terminal, where you can connect different peripherals. Currently what you are seeing, so here the processor is connected, and here DMA is connected, here Ethernet is connected, and it goes on like that. Okay, so just keep it in mind, this is just a connecting terminal or a connecting circuit, you can say. Now After this, we have a DMA controller. DMA stands for Direct Memory Access, which is used to transfer data from one device to other device without intervention of processor, that I'll discuss in detail later. And then we have Ethernet here, and then we have USB device as well. You can develop an application with the help of this USB interface. You can also develop a USB based application by using this microcontroller. And this yellow color, what you're seeing, this is a clock generating circuit. Externally, we have to give crystal oscillator, and internally from that crystal oscillator, there will be PLL, that stands for phase lock loop. With the help of phase lock loop, different types of clocks we can generate. We can generate high clock, very high end clock also we can, or low frequency clock also we can generate, and moderate frequency also we can. So it is all different possibilities. It is possible with the help of PLL, that also I'll be discussing in upcoming videos later. So we have ARM, and then we have, now coming into this part, what you're seeing, this is all about a memory. It talks about memory. We have 512 kilobyte of flash, and here the code will be stored. And then we have SRAM, static RAM we have, and 64 kilobyte of static RAM, and we have ROM here, it's a 8 kilobyte. Okay, this is about a memory part. And if we come down slowly, we have two different wings, or you can say we have two different bridges. In each bridge, one set of peripherals are connected. So you can see here, they have given AHB to APB bridge 1, or you can say you can see here APB group 0 and APB group 1. So we have two blocks, or you can say two different wings. In the first wing, they have given the name called APB group 0 and APB group 1. So it's nothing but different peripherals are connected to one set of wing, and one more set of peripherals are connected to one more wing. You can understand in that way. Okay, now in the first group, or APB 0, you can see here different peripherals such as SSP. SSP stands for Serial Synchronous Port. That all the things, whatever you are seeing on the screen, everything will be discussed in every single video in future. So I'm going to take each peripheral, each block, and I'll be explaining theoretically, and also I'll try to do the coding part as well in future. Okay, now, so in the APB group 0, we have SSP, that stands for Serial Synchronous Port. And then we have a UART here. So UART 0 and UART 1. UART stands for Universal Asynchronous Receiver and Transmitter. Basically, SSP and UART both are protocol. Then we have CAN here. CAN stands for Control Area Network, which is widely it is used in automobile industries. And then we have I2C 0 and I2C 1. Then we have SPI 0, Serial Peripheral Interface. So all these things, whatever you are saying, these are all our protocols, serial protocols: SSP, UART, CAN, I2C, and SPI. Okay, so all these things we'll be discussing in the later upcoming videos. Now here, capture and compare. So we have timers inside this microcontroller. We have different times. We have totally 4 general purpose timers are there, and all those things also we will be explained in the later videos. So these timers are used to generate the delay, and these timers are used to generate interrupt, and these timers are used to capture the time stamp. Okay, so timers are used in different applications. One, it is used in generating interrupt. Second thing, it is used in generating delay, and timers are used to capture some timestamp of some event. Okay, so for all these purpose, we're going to use the timers. Then we have Watchdog timer here. Watchdog timer is used as a protecting circuit to the microcontroller. Okay, so which will protect your microcontroller when your controller enters in error situations or error scenarios. So how that we will see later. Then we have PWM. PWM, you know that, pulse width modulation. We have totally 8 channel PWMs are available here. So using this, we can generate a PWM waveform. Then we have ADC here. We have a 12-bit ADC. ADC stands for analog to digital converter. With the help of this ADC, different sensors we can connect, and we can convert into digital, and we can do the processing. Okay, then 8 different channels or 8 different inputs we can give to this ADC. So then we have Pin Connect Block. Pin Connect stands for a different configurations we can do to the different pins of microcontroller. How to do that? That also we will see in the next upcoming videos. Then we have RTC here. This block, whatever you are seeing, RTC, that stands for real-time clock. The best example for RTC is your digital wristwatches. How digital watch is automatically is getting time is getting updated, dates are getting updated. So all these things are taken care by RTC. So RTC in your digital watches, RTC will be there, and that RTC is programmed so that automatically seconds, times, minutes, everything will get updated. So how to do the RTC programming, that also I will take care later. This is your APB slave group 1 or group 0, APB 0 we will call. And in the APB 1, it's similar to the APB 0. We have different peripherals like SSP 0 is there, the same thing what we have seen. And then second set of UARTs, UART number 2 and UART number 3. So totally 4 UARTs are there and 2 SSP protocol support is there. Then I2S. In I2S stands for inter-integrated sound. Okay, so that is I2S. Then the second I2C, like in the APB group 0, we have two I2C circuits, I2C 0 and 1, and here we have I2C 2 as well. Then we have repetitive interrupt timer. With this, we can generate a continuous interrupts from the timer. Then timers, currently in the APB group 0, timer 0 and timer 1 we have seen, and here in the group 1 or APB 1, we have timer 2 and timer 3. Okay, then we can generate external interrupts as well. We can generate a different interrupts from the external sources. So 4 different external sources are there with this microcontroller. That also we will explore in upcoming videos. Then we have a DAC, digital to analog converter. With the help of this DAC, we can generate a different waveforms like square waveform, rectangular waveform. Then we can generate sinusoidal waveform and so on. So we can convert digital data to analog data using with the help of this DAC. So with the help of system control, we can different functionalities we can do, like generating a different clock or enabling a different functionalities, different functions of a port pins and so on. So what is that? That also we'll see. And then finally we have motor control PWM and then quadrature encoder. So this is the brief architectural overview of your LPC1768 microcontroller. Okay, so in upcoming videos, I'll be taking each peripheral and I'll be doing every day or every one video, I'll come up with a one peripheral and one set of programming. I hope this is little clear to all. And with this, I'll just end my video here. In upcoming video, we'll meet again. So please subscribe my channel and get notification when we upload a new video. Thank you.